Welcome to this video on the refractive index of a prism, presented in a Viva Voce format. We'll cover fundamental concepts, experimental procedures, and advanced analysis related to this classic physics experiment. The objective is to determine the prism's refractive index for various wavelengths using a mercury vapor lamp and a spectrometer. The governing formula is mu equals sine of A plus dm over 2 divided by sine of A over 2, where dm is the angle of minimum deviation. Let's test your knowledge. The condition for minimum deviation is when the angle of incidence equals the angle of emergence. A mercury vapor lamp is preferred to get a discrete line spectrum for precise measurements. Also, the refractive index decreases as the wavelength increases. Let's continue the quiz. The prism formula, mu equals sine of A plus delta m over 2 divided by sine of A over 2, relates the refractive index to the angle of the prism and the angle of minimum deviation. Immersion in water decreases the angle of minimum deviation. Violet light has the maximum angle of deviation. Moving on to quick quiz 3. The relationship between critical angle and refractive index is mu equals 1 over sine of circa. For a thin prism, the angle of deviation is approximately mu minus 1 times A. Finally, dispersive power depends only on the nature of the prism material. In Quick Quiz IV, we revisit key concepts. At minimum deviation, the angle of incidence equals the angle of emergence. I equals E. Violet light suffers the maximum deviation. When a prism is immersed in water, its dispersive power decreases. Quick Quiz V focuses on key formula and relationships. The governing formula is mu equals sine of A plus dm over 2 divided by sine of A over 2. Refractive index decreases with increasing wavelength. We use a mercury vapor lamp for discrete wavelengths. Now let's explore fundamental concepts. The collimator's main function is to produce a parallel beam of light. A narrow slit is used to ensure sharp, distinct spectral lines. The condition for minimum deviation is when the angle of incidence equals the angle of emergence, and the refracted ray is parallel to the base. For advanced analysis, the refractive index is calculated using the prism formula at minimum deviation. If the angle of incidence increases beyond minimum deviation, the angle of deviation increases again, forming a U-shaped curve. Dispersion happens because the refractive index varies with the wavelength of light. Let's review angle analysis. The relation between angles is I plus E equals A plus delta. Conditions for minimum deviation include the angle of incidence equaling the angle of emergence, and the refracted ray inside the prism being parallel to the base. The angle of deviation is directly proportional to the refractive index for a thin prism. Continuing with advanced concepts, the refractive index is given by mu equals sine of A plus delta m over 2 divided by sine of A over 2. Immersion in water decreases the angle of minimum deviation due to a reduced relative refractive index. Per Cauchy's relation, the refractive index decreases as the wavelength increases. Here are the essential formulae: the prism formula for refractive index, the thin prism deviation formula, Cauchy's relation showing the inverse relationship with wavelength, and the critical angle relationship, mu equals 1 over sine of C. Thank you for watching this physics guide. We hope it was helpful for your laboratory experiments. Please like, share, and subscribe for more educational videos.